morning, everyone. Any questions? Number 59. Oh, okay. I will look at all of them and see which one. I will not do the same problem twice. So it's 50, 51, and 59. Did I assign number 50? So 51 and 59 are fairly similar in nature. So I will pick one of them. So I will pick number 51. Did I assign number 50, Zach? Okay. All right. So we have to evaluate this integral. It's a definite integral, so we can worry about that at the end. So that's not an issue. So basically, we have to focus on the antiderivative of this function. So that's really, we have to be our focus. And then at the end, we go to the definite integral and apply the fundamental theorem. All right. So again, we look at this function. That's a typical irrational function. It means that's a polynomial of degree 1 over a polynomial of degree 2. Substitution will not work because even if I put u to be the denominator, because that's the only possible substitution here, its derivative is going to be 2x plus 2, which is it's nowhere inside. So that's really has to be scratched. So I always really think, will substitution save me? It doesn't. So we have to take the denominator and factor it out. If I cannot factor it, and then I have to complete the square. So let me see. B squared, it's a 4 minus 4ac. This cannot be factored. So we write it down just to make sure we know that. We have b squared minus 4ac is equal to 4 minus 8, which is negative, so cannot be factored. So if I cannot factor, then I have to complete the square. That's really the process. So we complete the square. Okay, so let us remember how we complete the square. So that's the expression equal to x squared plus 2x. Coefficient of x is a 2 divided by 2, it's a 1. I add a 1. That's going to be my complete square. I take away 1 and I add 1. So this would give me x plus 1 squared plus 1. Okay. So now my integral become integral of. So I will have x. So this would become x over the quantity x plus 1 squared plus 1 dx. Okay, so it becomes much, much simpler. Now I make the small substitution, u equal x plus 1. My du is my dx. And then this would become, and here we have to be very careful. Denominator, u squared plus 1. Dx is du. But now I have the x. I need to write it in terms of u. This x here becomes u minus 1. So this x will become u minus 1. So this will become u minus 1. And now, yesterday we saw how to deal with this type of integral. The only way I can evaluate this is by splitting the numerator. The only way is splitting. So this will give me u over u squared plus 1. That's the only way to do that. Minus 1 over the u squared plus 1. Okay. Now each integral by itself has to be taken care of. Now this one is easy. That's the arctangent. And this one is arctangent because this is a 1 here, so it's just arctangent x. That is not, arctangent u. This one, it needs a little bit of work. It needs a little bit of a substitution. So this one here, I can do that very easily. So that's we put t to be u squared plus 1. The dt is the du. This would become half 1 over t dt. It means a half ln of t. It means a half of ln of u squared plus 1. So at this stage, we are actually done. We still have only, so finally I will get, this is equal to. The first term is a half the ln. I don't need the absolute value because u squared plus 1 is positive. Minus. The second one will give me arctangent u. I go back to my original variable. So as you realize, in this case, I did not change the limit at the beginning. I wanted to evaluate the integral, and then at the end, I will use the fundamental because there are so many substitutions in the problem. So finally, I will have that. Minus arctangent x, x plus u is x plus 1. Okay. Now I go back to my definite integral. So the definite integral is to find my definite integral. So integral from -1 to 0 of x over x squared plus 2x plus 2 dx will be equal a half the ln minus arc tangent x plus 1 evaluated between -1 and 0. Okay, so I did this at the end because I will be comfortable doing anything I want to evaluate the indefinite one. And now we just substitute. There is not much left. So it's going to give me at the upper minus at the lower. So at the upper I will have a half ln. If x is 0, that's going to give me 1 plus 1. So it's ln of 2 minus arc tangent x plus 1 arc tangent 1. So that's the end of the first one. Minus, so I can make this smaller now, minus. At the bottom, I will have half ln. If x is -1 plus 1, it's 0. I will have ln of 1 minus arc tangent. If x is -1, arc tangent 0. And then those are, some of them are easy to evaluate. So I will have half ln of 2 minus arc tangent 1 means the angle whose tangent is 1, that's pi over 4. ln of 1 is 0, arc tangent is 0. And of the problem. Okay. Now 59 is basically verbatim the same. Verbatim. The only thing is that instead of having this one will be completing the square will be slightly different. Otherwise, it's the same. So I will not do number 59. Right, now number 50. Let's see what this is about. Integral of from 4 to 9. I don't remember I assigned 50 for some reason.
You didn't. That was from section 8.5.
Thank you. I mean, it's not like a big deal, but I haven't done problems along those lines yet. That's why I don't think I did assign it. I probably should assign it tomorrow. All right. So let me look at 8.5 and proceed. Okay. So 50 and 51. All right. So 50 and 51 are about basically what we'll be talking about today. So I will not do them, but I will do very similar, and it will be up to you to do them. Is that clear? So that's really how it will, because those will be assigned today. As I told you yesterday, section 8.5, I'm not sure you can do them. So I'm going to do similar to them, and you guys will do those by yourself. So let us see what we did yesterday. So yesterday when I left you, we took care of the pieces in the partial fraction decomposition. Now we're going to do the whole picture. So let me see which integral I take. So suppose I take the following integral. All right, here we are. X plus 2 over x cubed plus x dx. Okay, and we need to evaluate this integral. So the approach is, again, we're going to study that. That's a polynomial, and that's a polynomial. So it's a polynomial. As we said, substitution totally failed in this case as well. So we do partial fraction decomposition. So we're going to take this piece. And the first step in a partial fraction decomposition is to fully factor the denominator. X squared plus 1. Okay. Once I do that, I analyze the factor. That's a linear, non-repeating. So the contribution to it is a over x. This cannot be factored, so its contribution is bx plus c over x squared plus 1. Okay. Now we do exactly what we did. We multiply across by the common denominator. So multiply across by x times x squared plus 1. All right, what do I get? If I multiply this term, I will have x plus 2 equal. I will multiply a over x by this, I will have a over x squared plus 1 plus. I multiply that, I will have x times bx plus c. Okay. And now we need to find the constant a, b, and c. All right. Now there are, as I said, two ways to do that and to find the constant. And each problem, one way is easier than the other. Okay. So I will do it the way that I've been doing it by picking values, and then I'm going to do it the second way by assembling coefficient of x squared together and x together. Right, so the first approach is we pick specific values of x. Now, which value of x will be the easiest to pick? Anybody?
0.
0, because there is nothing that will make x squared plus 1 0. So I cannot really get rid of a by any stretch of the imagination, because nothing will make this expression 0. It's irreducible. So this I will have to deal with it. If I look here, if I put 0, I can basically fill up my a. So I'm going to take x equal to 0, and that's what give me 2 equal a. So I have a of the back. That's easy. Now I need b and c, and that's really the problem. As I said in this one, there is nothing that will get rid me of a. So I'm going to do the following. I'm going to take any value of a. Of course, if you take easy value, otherwise it will not be smart. I will have 3 equal 2 times 2 actually plus b because x is 1 plus c. And this will give me b plus c equal 3 minus 4 minus 1. Okay. Okay, I mean, you tell me, okay, but you didn't get any of them. I agree, I didn't get B or I didn't get C, but we're going to do the following. I'm going to take another value, a simple one, like minus 1. I will have minus 1 plus 2, it's a 1, equal. Minus 1 squared, so this is going to give me again. And now, if I plug in minus 1 for x, I will have minus b plus c. So this will give me 1 equal 4 minus minus plus b minus c. So this would give me b minus c equal 1 minus 4 minus 3. So now, even though I couldn't pull b and c immediately, but I have two equations relating them. So now I solve those two, and they are relatively simple equations to get the b and the c. So we have b plus c equal minus 1 and b minus c equal minus 3. And now I need to find the b and the c. How can I find them? Okay, so using this process, I couldn't pull all of them immediately. I was able to get a off the back immediately, but I picked two other value of x, but they gave me this. So how can I find the b and the c? Anybody?
If you add the two equations together,
exactly. Just add them. Plus c minus c, so add equation. That's the easiest way. I will have 2b equal minus 4. I get b equal minus 2. I have my b. And then I need my c. I can use either equation to get a c. So I can use this equation now to get my c down here. And I will get c equal minus 1 minus b. I know my b, it means minus 1 plus 2, which is equal to 1. So I get my c. So now I'm almost there. So now finally, what does this tell me? Tell me that.
I have a question.
I'm listening.
How did you get B again? I'm a little confused on that.
Did you understand how I got those two equations?
Yeah. You just put in just a random number for
right.
For the
I
first
don't pick,
part.
I pick easy numbers, of course, 1 and minus 1. I will not pick anything hard. The random number I can, but I pick easy one. Now it means now I have two equations in B and C, and I need to solve for it. Okay, two equations to unknown. There are several ways to do that. One easy way is that add those two equations. If I add them, what do I get? The c and the c cancel out. B plus b, 2b, minus 1 plus minus 3 give me minus 4.
Oh, okay.
See what I did? I mean,
yes.
Your classmate actually suggested. We just added them because it's easy. Okay?
Yes, thank you.
So this is going to give me equal to A, it's a 2 over x. B is minus 2 x. C is plus 1 over x squared plus 1. Okay, so now my problem is way simple. I transformed a complicated expression into the sum of simpler equation, simpler expression. Now I integrate. And we're there, we're almost done. Okay, so now I would get integral of x plus 2 over x cubed plus x dx. It's the antiderivative of 2 over x dx plus the antiderivative of minus 2x plus 1 over x squared plus 1 dx. All right? Now, each one. This is the easy piece. So I can get this out, 1 over x dx. This one. How do I do this piece?
Are you going to use substitution?
Let's try it. If I put u equal x squared plus 1, that's the substitution you want, right?
Yeah.
So if I put u equal x squared plus 1, what's the du?
2x dx.
2x dx. Okay, this is the u. How I'm going to put the 2x dx?
You can't because it's a sum.
Exactly, exactly, exactly. I can't. So this has to go. Okay, you guys always try it. What do you want me to do?
What's the
sum-
fractionator?
What?
Put the numerator or like the top in the fraction like you did
Exactly.
in the
We have
problem
to
before.
break the, we have to split the numerator. No way out. And then I will do the substitution for one of them. I have to split the numerator into this expression and this expression. So you guys, if you're taking note, write in red, split the numerator. Split the numerator. Split the numerator, crucial. And now at the end of it, find it is equal to 2 ln of x minus, now this integral here, this is where the substitution your classmate mentioned work, only on this piece, only on that piece. This one is easy, that's the arctangent x. It's only x even, there is nothing else. So finally I will end up with 2 ln of x minus this one. Here, the substitution u equal x squared plus 1 will work because the du in this scenario is the 2x dx, which is totally right there in front of us in the numerator. So this piece will give me the ln of x squared plus 1 plus arctangent x plus c, and of the problem. Okay. Now, I'm going to go back to finding the coefficient, and we're going to find the coefficient in a different way, because sometimes the other approach, which I mentioned before, but now I'm going to again talk about it, it's sometimes easier than picking values. So let us go back. Important, basically. So let us find the coefficient in a different way. Let us find ABC in a different way, just so we can practice both of them. So this is the relationship that we use. This is the equation that we use to find the coefficient, A, B, and C. So let's see how does this work. It works like this. We basically distribute here. So ax squared plus a plus bx squared plus cx. Right? And then we combine the term in x squared together, the term in x together, and the constant term. And then we say the following. So that's x plus 2. The coefficient of x squared here, which is a plus b, is equal to the coefficient of x squared in this piece. Because we say that those two expressions has to be equal for all x. Means coefficient of x squared here equal coefficient of x squared here. Now, of course, as you see, there is no coefficient, but this means that this is 0x squared. That's what it means. So now I identify, I say a plus b, for this to be equal, should be the same as 0. So I come up with my first equation, equal to 0. The coefficient of x here is c. It should be the coefficient of x here, which is a 1. So it means c should be equal to 1. and A should be equal to 2. So in this problem, this approach is easier. So now I have my A and I have my C, and this would give me the B equal minus 2. Okay, so in this type of problem, this approach is easier than plugging values. So every problem is different. The one where we have a linear factor, no quadratic, picking value is easier. When we start having quadratic, sometimes this approach is easier. So it really depends on the problem, all right? Okay, so now you should be ready to finish your homework 50 and 51. We still have one piece to basically wrap up this whole section, which is a lot of little pieces. Now, everything we did so far, I kept telling you without explaining it, that works when the numerator is smaller than the denominator. So I will try to give you an idea why that's the case, and then we will do what to do when the numerator has a degree larger or equal to the denominator. So let us see why things fail. You don't have to write, but you just have to listen. Let us say I have x squared over x times x minus 1, okay? And I need to integrate that. And no substitution is inside, obviously. Here, I want to do partial fraction decomposition. And let us say I do what I've learned. So parentheses, the degree here is 2, the degree here is 2. And we're going to show you that this is not going to work. So I will have a over x plus b over x minus 1. Okay. And let us say I proceed exactly the same way. I multiply across by this expression. I will have x squared equal. If I multiply a over x by this, I will have a times x minus 1 plus b times, so I will have bx. So here I'm going to tell you, note degree of the numerator equal degree of denominator. So that's really my problem here. But now watch what the issue happened. Why this is impossible to occur. So why this is impossible to find a and b so that this expression equal this expression. Why this is impossible?
Is it because there's no x square values?
Exactly, exactly. This is, you want those two functions to be the same. This is a linear function. So if this is a line, this is a parabola. There is no way you can have a line and a parabola coincide for all values of x, because you want this to hold for all values of x, no matter what x is. There is no way this can hold, because there's an x squared here, and there is no x squared inside in this particular problem. So whenever the degree of the numerator is going to be bigger or equal to the degree of the denominator, this approach will absolutely be impossible to happen, because I cannot have a degree 1 equal to degree 2. So there is no x squared here, and there is an x squared here. We cannot really work with that. Okay. So what do we do? So my last case is going to be, what do we do when the degree of the numerator is larger than the degree of the denominator? So that should be the last case that we're going to do. So how to integrate, how to find integral of p of x over q of x dx when the degree of p of x is bigger or equal to the degree of q of x. And then the whole picture will be. And the idea is, that's the main idea. The idea is we can perform what we call the log division. The idea is we need to perform log division, and then I will remind you how to do that, and then proceed. Okay, So we have to perform long division and then we proceed. All right, so let us see how do we perform long division and what's the benefit of the long division. Now, before I do long division for polynomial, I need to remind you how to do simple division, okay? So suppose, let's go back a little bit to, I don't know, middle school or elementary school. And suppose I'm going to divide, I don't know, 33, let us say, into 2. Okay, let us remember that. All right. So we take the 3, we divide it into 2, so that it's a 1 here. We take 1 times 2. You don't have to write this, I'm trying to remind you. 1 times 2, it's a 2. So you take away a 2, and then you get a 1 and a 13. Then you divide 13 into 2, which is a 6. 6 times 2 is a 12. And you get a 1. Okay, that's how you do long division. All right, but what does this mean? And this we called it, if you guys remember, do you remember what you call this one here?
Remainder.
Remainder. And this called the quotient. But what does this mean? That's really what I care about. Means when you divide 33 into 2, you don't get exactly 16. You get 16, and that is a remainder of 1. Okay, so this means that 33 is equal to, there is not 16 in 33. There are not 2 16 in 33. So it's 2 times 16 plus the remainder. When you divide 33 by 2, you get 16 plus the remainder. So this tells me that if you take 33 divided by 2, I'm going to divide by 2 across, it's going to give me the 16 plus a half. That's what it means. It means 33 divided by 2 is the 16 plus a half. This one here is the remainder. That's important. And this is the quotient right there. Okay, but that's really what the division means. All right, why we're talking about that, why we're taking you back to elementary school, because we're going to divide polynomials. And I have to remind you how to divide polynomials. So the problem is, my goal is to find this complicated integral. I took it a little bit complicated so I can divide well in front of you. So my goal is, that's really my goal, to find this antiderivative, x squared plus 5x plus 6. So if you just look at it, it's kind of a scary something to integrate. And that's really my goal here. Now let us notice the following. That's a rational function, polynomial over a polynomial. And here the degree of the numerator is larger than the degree of the denominator. This is 3 and this is 2. So we're going to perform division first. And now let us perform the division, and we see what's the benefit of the division, which is going to make a parallel with this piece I'm talking about. So let's perform the division. All right, let's see how it works. So I have x cubed x cubed plus x squared divided by x squared plus 5x plus 6. Okay, so that's a division I need to perform. All right, so let's see how do we do it. Okay. Like we did before, we take the highest power of x here, which is x cubed. We divide it by x to the highest power, which is x squared. X cubed divided by x squared, give me x. Okay, and then I multiply x by the divisor and I subtract. So minus the following: x times x squared, x cubed, plus 5x squared, plus 6x. and I subtract from each other. I will have x cubed minus x cubed is a 0. X squared minus 5x squared, which is going to give me minus 4x squared minus 6x. Okay, so I use this problem to remind you how we divide. Then I take the x, the highest power here, which is minus 4x squared, and divide it by x squared. So minus 4x squared divided by x squared is going to give me minus 4. And then, as I did before, we multiply minus 4 by this expression, and then we subtract. I would get minus 4x squared minus plus minus 20x minus plus minus 24.
I have a question.
I'm listening.
Can you repeat how you found the -4?
Yeah. What is the largest power of x here? Minus 4x squared, all right? We divide it by the highest power of x here, which is x squared. So you get minus 4x squared divided by x squared, which gives you minus 4.
All right. Thank you.
And then you followed me after that. Minus, you take the minus 4, you multiply it by this expression, gives you minus 4x squared, minus plus minus 20x minus 24. And then you perform. The whole idea is to get rid of minus 4x squared. I'll have minus 4x squared minus minus cancel each other out. Minus 6x minus minus plus 20x, 20 minus 6, that's going to give me 14x. And then there is nothing here, plus 24. Okay. Now, we stop the division. We stop when the degree of the remainder, if you want, is less than the degree of the denominator or the divisor, less than degree of denominator. That's when we stop our division. Yeah, we carry the negative of 4, absolutely. Minus 4 we carry it when we multiply it by this expression. All right, now this is, in this case, we're going to call that the remainder. That would become the remainder in this scenario. And we stop the division when this is the degree here is 1, the degree here is 2. We stop the division when the degree here is less than the degree of the denominator. But what does this mean? And that's really what we really care about. This tells us the following, and that's the important part here. What does this division tell us? It's exactly like it did in the previous scenario. It tells me that if I take x cubed plus x squared and I divide it by x squared plus 5x plus 6, this is equal to the following. It's equal to the quotient, x minus 4, that's the quotient, plus the remainder, that's the remainder divided by the denominator. That's the most important part. Okay, so this tells us exactly that. If I take x cubed plus x squared, I can write it. So that's the quotient here. That's what we call the quotient. It means what we get right there. That's the quotient. And this is the remainder. And this is the denominator, or the divisor, or the denominator in our scenario. All right, that's really what it tells us. And how can we make sure it's correct? The only way you can make sure is you start from here, from the bottom, find a common denominator, you should get this expression. So what I'm telling you that they are the same, absolutely the same, but this would be easier to integrate. Now, why is this easier to integrate? Why writing it like that will make integration easy? Let us analyze each piece. This is easy to integrate, no question asked. What about that? What's the benefit of doing this division? You can tell me.
Would it be that the degree of the numerator is now less than degree of the denominator?
Exactly. In this piece, the degree is 1. Here the degree is 2. So the degree of the numerator is less than the degree of the denominator. We know how to handle this piece by now. So the goal of the division is to create a situation where the degree of the numerator is less, and then we can use what we've learned to be able to evaluate this integral. So now we can go back and integrate, and that's it will not be hard anymore. So let us go back. So now the integral of, even though it's going to take us a little bit, but that's really the goal of this long division. It actually brings me back to my previous scenario. Divided by x squared plus 5x plus 6 dx will be equal to the integral of x minus 4 dx. So that's really what this is giving me. That's the crucial part, plus the integral of 14x plus 24 divided by x squared plus 5x plus 6 dx. Now, this is nothing. This is a half x squared minus 4x. This piece is going to require a little bit of work, but we know how to do that. So we're going to isolate this one, evaluate it, and then put the whole picture together. So let us evaluate the integral of 14x plus 24 over 6 dx. Okay. So now this is bringing me back to my previous scenario. The degree here, so let us note that the degree of the numerator here is less than the degree of the denominator. Okay, so we're back in our previous scenario. So the only way to do it is, no substitution is going to be inside, is partial fraction decomposition. Okay, so in partial fraction decomposition, I only have one quadratic term. So we ask ourselves, can I factor this quadratic term? We don't start completing the square. We ask ourselves, can I factor this? Okay, what's your answer?
Yes.
Yeah, immediately. Because b squared is 25. 25 minus 4 times 6, that's 24. This could be factored very easily. So I factor. You don't jump into completing the square because we've learned it. You first ask yourself, can I factor? If you can't, you jump into completing the square. So that's going to give me plus 24 divided by, okay, 3 and 2, x plus x plus. And now this is a over x plus 3 plus b over x plus 2. Okay, and now multiply across. It will give me 14x plus 24 is a times x plus 2 plus b times x plus 3. Okay. Now in this scenario, picking special value of x is the easiest way to go. So it's easier than putting the coefficient of x together and the constant term together, because I get my values off the back immediately. So I will take x equal minus 2, and I solve for a, and we will get, let me see, what do I get? I get a equal minus 4. You guys know how to do that now. I pick x to be minus 3, and I plug it everywhere, and I will get my b to be equal 18. Right, so now I have it. So now I know that the integral of 14x plus 24, so I have this complicated piece. Equal integral of a over x plus 3, it means which is going to give me minus 4 ln of x plus 3 plus b, which is 18, ln of x plus 2. Okay. And now finally, I put the whole integral together, which was a long process, but it's, we have to do it. So now I go back to my initial integral. So integral of x cubed plus x squared, so that's my initial one, will be equal to, now I took care of this piece is easy. It's a half x squared minus 4x, and this one gave us minus 4 ln of x plus 3 plus 18 ln of x plus 2 plus 3. So whenever the degree of the numerator is larger, then we have no way out. We have actually to divide. Once we divide, we are in a good shape. Let me do another one, which is much, much simpler because we don't have a lot of time left. Much simpler, but the same approach. So another example. Suppose I ask you to evaluate the following. Suppose x squared, okay, x squared plus 1, for example, over plus 4 dx. Okay, it's simpler, I guess, than the previous one. So again, we're going to analyze this. We have degree issue. Both degrees are equal. So we have to divide. Okay, so let's divide. So we need to divide. So whenever you have the integrand, you actually ask yourself, so here degree of the numerator is larger or equal. We have to divide. All right, so let's divide. Into that. All right, and this will give me 1, x squared over x squared plus 4. And then x squared minus x squared cancel each other out. 1 minus 4 would give me minus 3. I stop because the degree here is less and the degree is 0, less than the degree here. But what matters is, what does this tell me? That's really what matters. That's when I take the expression x squared plus 1 and I divide it by x squared plus 4, what should I get? Quickly.
1 minus 3 over x squared plus 4.
1 minus 3 over x squared plus 4. That's really what it tells me. That's the quotient, and that's the remainder over the denominator. Now, if you find a common denominator here, you're going to get that. So it means I do it here on the side. The common denominator in this expression to the right is x squared plus 4. So if you find a common denominator, you're going to get x squared plus 4 minus 3 over x squared plus 4. 4 minus 3, that's going to give me 1, is x squared plus 1 over x squared plus 4. I'm not changing anything. I'm just rewriting so I can solve. So now my problem is simple. As you realize, I rewrote it in it so I can do it very easily. Minus that. Okay. Now, every piece here is simple. The first one is dx. The second is 3 times the integral of 1 over x squared plus 4 dx. So finally, this will give me the following. The first one is x minus 3 times. That's the arctangent, where my a is 2. So it's 1 over a arctangent x over 2 plus 2. So my a here is 2 because that's x squared plus a squared. And of the problem. Okay. All right, with that, we basically finalize all the possible scenario. So we finalize what we have to do with every possible rational function. It means p of x over q of x. We know how to do all of them, and it really depended on the degree and on the factors of the denominator. Okay, so once the degree of the numerator is less, and then it's the factor of the denominator which actually control the picture. If we have linear, we can decompose it in one way. Linear repeating, we have another decomposition. Quadratic that cannot be factored, then we have a third decomposition. Once we decompose, the pieces are usually easier to integrate. Okay, any questions? Any questions? Okay, so now you can finish the homework that I assigned yesterday. I know some of you did finish it, but you guys can finish, and I'm going to assign probably 2 more problems from the new material. All right, I will do that in a minute. Okay, any questions? All right, bye-bye, guys.
Bye.
Have a good day.
Yeah,
Goodbye.
thank you. Bye.